All right, today's lesson in our unit factors and multiples, we're looking at finding the greatest common factor. But before we do so, let's do a quick review of prime factorization using the factor tree method and the repeated division method. So let's say we are trying to prime factorize the number 36. So we would find any two numbers that go into 36. So two numbers that are the factors of 36. I'm just going to use 2 and 18. All right, 2 is already a prime number, so we would continue to factor 18. So two more numbers that give me 18. Let's just use 2 and 9, because 2 times 9 gives me 18. 2 is already a prime factor. Let's keep going. We can use 3 and 3 for 9. So now all our numbers here are prime numbers. So the prime factorization of 36 would be 2 times 2 times 3 times 3 to give me the 36. So that was the factor tree method. The other method we talked about last class was the repeated division method, which I'll do over here. Same number, so let's do the number 36. So we set it up like this. And the numbers we choose on the left-hand side, they have to be prime numbers. All right, so we can use 3 or 2. Let's use a 3 this time. 36 divided by 3, that gives me 12. And then we can divide by 3 again. 12 divided by 3, which gives me 4. 4 we can divide by 2, which gives me 2. And then 2 divided by 2 to give me the 1. So notice on the left-hand side, these are our prime factors. They are the exact same as when we did it by factor tree, 2 times 2 times 3 times 3. So same answer both ways to get the prime factorization of 36. So that was just a quick review from last class. So let's say we had to figure out the greatest common factor of 12 and 18. So let's say the question was find the greatest common factor, I'm just going to abbreviate it to GCF, of 12 and 18. So one method you learned in the past was to write out all the factors. So for example, for 12, the factors would be 1, 2, 3, 4, 6, and 12. All right, 1 times 12 gives me 12, 2 times 6 gives me 12, and 3 times 4 gives me 12. And then we would do the same thing for 18. We would write them all out. So 1, 2, 3, 6, 9, and 18. And then you would check the greatest common factor for both of them. So here it would be 6. So therefore their GCF of 12 and 18 would be 6. But since we've learned prime factorization, we are going to find the greatest common factor using our methods of prime factorization. Okay, so let's say we had to find the greatest common factor of 24 and 60. So the numbers are getting larger. So it's going to be harder to write out all of the factors. So what we do here is use the methods. So let's use our factor tree method to get the prime factorization of 24. So I'm going to use 2 and 12. And then let's use 2 and 6. And then let's say 2 and 3, because those are the only two factors. All right, so for 24, we have 2 times 2 times 2 times 3. So I'm going to write that out. 2 times 2 times 2 times 3. All right, next I'm going to do the prime factorization of 60. And I'm using the factor tree method. I'm going to use 2 and 30. And then I'll use for 30, 2 times 15. And then for 15, it's 3 and 5. All right, so 2 times 2 times 3 times 5. So what I'm going to do is list it out here as well. Now what I'm going to do here is list it out underneath, right underneath. So the same factors right underneath each other. So 2 times 2, we have a times 3, and then we have a times 5. I put it on the outside because there wasn't a 5 for 24. So now I can find my GCF by looking at what's common. So 2 and 2, 2 and 2, and 3 and 3. So now all I do is multiply 2 times 2 times 3, which gives me the greatest common factor of 12. The other way you could have done it is when you did your factor tree like this, you can circle the ones that are common. So 2 and 2, 2 and 2, and then we have a 3 and 3. So the GCF is 2 times 2 times 3, which is equal to 12. So second example, we're going to find the greatest common factor of 42, 56, and 140. So we're starting by prime factorizing each number. So for 42, I'm going to use 7 and 6, and then 2 and 3. So that's complete for 42. I'm just going to write it out here. For 42, so we have 2 times 3 times 7. Next we have 56. So for 56, I have 7 and 8, and then 2 times 4, and then 2 times 2. And I'm going to list that out here as well. Remember to list it out right underneath the common ones. So we have 2, and then we have the times 7, and then we have 2 more 2s. So I'm going to list them out here. All right, and then we still have 140 to do as well. So 140, two numbers that go into 140, I'm going to use 2 and 70, and 7 and 10, and then we have 2 and 5. So same thing here, I'm just going to list them out right here. For 140, we have a 2, we have a 7, we have a 2, and then we have a 5. All right, so we're only going to use the ones that are common to all three numbers. So that would be 2 and the 7s. So therefore, the greatest common factor is going to be 2 times 7, which is equal to 14. Now we can do the same thing here. If we see a common number here, we see the 7, 7, and we have a 7. And then we have a 2, 2, and 2. So same sort of deal if you were doing it, looking at just the factor tree. The GCF, it is 2 times 7, which is 14. All right, so the greatest common factor of 42, 56, and 140 would be 14. All right, so we're going to use factor tree to prime factorize 12. So I can use 3 and 4. 3 times 4 gives me 12. And then 2 and 2, like that. So for 12, it is 2 times 2 times 3. And then for 18, I'm going to use 3 times 6, which gives me 18. And then 2 times 3. All right, so just listing it underneath here, right underneath the same ones. So I can put here the 2 times a 3, and then another times 3. So our greatest common factor is what's common between both. So 2 and the 3. So 2 times 3, which is 6. All right, and the other way you could have done it is finding the common ones between the 2 like this. So GCF is 2 times 3, which is 6. All right, which is the exact answer that we had found when we had listed out all the factors of 12 and 18. All right, so next we are going to look at how do we use the repeated division method. All right, so here we have 60 and 84, and we want to find the greatest common factor of 60 and 84 using the repeated division method. So we're going to put the numbers 60 and 84 at the top like this and set up our repeated division like this. And what we want to do now is find factors on the left. They has to be a prime number, and it has to be a common factor of both numbers. So looking at 60 and 84, I'm just going to use 2 because they're both even numbers. So start by dividing by 2. So 60 divided by 2, that gives me 30. And 84 divided by 2, that gives me 42. And we're going to continue. 30 and 42, again, they're both even numbers. So just go ahead and divide by 2 again. And we get 30 divided by 2, which is 15. And 42 divided by 2, which is 21. Okay, so now we have 15 and 21. They're both odd numbers, but yes, they are divisible by 3. 15 and 21 both are divisible by 3. 15 divided by 3 is 5, and then 21 divided by 3 is 7. And what we're going to do is when there's no other numbers that we can divide here, then we stop. So here is when we stop. All right, so 5 and 7, we don't have a number we can divide both of them by. So looking on our left-hand side, our greatest common factor is these that we see on the left. So 2 times 2 times 3, which is equal to 12. All right, so again, you're multiplying those numbers on the left-hand side to get the greatest common factor. So next example, we're going to use repeated division again. We're looking for the GCF of 60, 150, and 135. So let's set that up. So 60, 150, 135. And we're just going to set it up for repeated division. All right, so 60, 150, 135. All three of those numbers are going to be divisible by 5. All right, because they ended with 0 or they end with 5. All right, and 5 is a prime number. So 60 divided by 5, this gives me 12. 150 divided by 5 is 30. And 135 divided by 5 is 27. All right, and if you do need to use your calculator here, feel free to use your calculator. All right, so now we have 12, 30, and 27. So we're going to have to think here, what number are all three numbers divisible by? So 12, 30, and 27. All right, sometimes you might have to do a guess and check if you are not so confident with your multiplication tables, and that's perfectly fine, but it is the number 3. Okay, 3 goes into 12, 30, and 27. Yes. Okay, so 12 divided by 3, that is 4. 30 divided by 3 is 10. And then 27 divided by 3 is 9. All right, so look at those numbers here, 4, 10, and 9. This is where we're going to have to stop, right? We're going to stop here because there's no other number that's going to divide into all three of these numbers, 4, 10, and 9. So this is where we stop. So stop when no other number divides into all three. To all three bottom numbers. All right, so we're just going to look on our left-hand side here. We have 5 and 3. So therefore, the greatest common factor is 5 times 3, which is equal to 15. All right, so the greatest common factor of 60, 150, and 135 is 15. All right, for this question, we are using the prime factor method to find the greatest common factor of 100, 150, and 125. So I've already completed 100. I got 2 times 2 times 5 times 5. So next I'm going to prime factor 150. So two numbers, I'll use 3 and 50. And then I'll use 2 and 25. And then 5 and 5. All right, so listing it out here for 150, we have 2 times 5 times 5, and then we have the 3 that is not common to both. All right, next, let's look at 125. Two numbers that multiply to 125 are 5 and 25, and then two factors of 25 is 5 and 5. So listing that here for 125, we have a 5 times a 5, and then an extra 5 on the outside. So looking at what's common to all three is 5 and 5. So therefore the GCF is 5 times 5, which is equal to 25. All right, and we can do that when we did the prime factor trees here. Look at 2, 2, 2, and there's no 2 here. For 5, we have a 5, 5, and a 5. 2 we already checked, and then 5, 5, and 5. All right, so looking at it that way, also you would get 5 times 5, which is 25. All right, so the greatest common factor of 100, 150, and 125 is 25. All right, last one for you guys to try. Try this one. We have 36, 90, and 105. So this time you're going to use the repeated division method. So set that up like this. So 36, 90, and 105. Oops. All right, so we have 36, 90, and 105. So we're going to find a number that's a prime factor, and that goes into 36, 90, and 105. So we're going to use 3. And so 36 divided by 3, that gives me 12. 90 divided by 3, that gives me 30. And 105 divided by 3, that gives me 35. All right, so now 12, 30, and 35. There's no number that will go into all three of those numbers. So that is where we have to stop. So greatest common factor here, looking on the left-hand side, is just equal to 3. All right.